Okay, students, now moving towards the next part of the previous video which we have seen. In that, we discussed about the basic introduction of NMR spectroscopy. If you haven't seen that video, so first kindly see that video so that you could understand what we are saying in this video. Because if you will be having the concept, the initial concepts which we have given in the previous video, then you will be able to learn what we are telling in this video. So let us start this video now. So in this, firstly, what we are going to do is, this is a graph. This is a graph. Here it is carbon 13 NMR graph. 0, 10, 20, 30, and then you'll be like 80, 100, 120, 140, 160, 180, 200. It will be like this. These are all the ppm values. These are the ppm values, and here we'll see different peaks here. So the peak which will be present at almost 10, a kind of a peak will be present here. So firstly, let us label here. It is carbon 13, so that you could easily understand what is this carbon 13 NMR. This is carbon 13 NMR. Here you will see a peak at 10 ppm, then a peak at almost 25 to 30 ppm, then at about 60 ppm. After that, you will see at 120 ppm a peak. After that, at 160 ppm, then at about 220 ppm. So these are the peaks of carbon 13. What does the peaks in the graph show us? So let us move here. So firstly, we'll see how many peaks are there. 1, you will see like this: 1, 2, 3, 4, 5, and 6. Here, one thing to remember, at about 80, you will be able to see a kind of 3 peaks here. So as I have explained in the previous video, you will have to neglect these peaks which are present at 80 ppm in carbon 13 NMR, because these peaks predict us about the solvent. These peaks are of solvent, and these are of no use in your in predicting the compound. So you have to ignore these peaks, ignore the peaks which will be present at 80. So what we have seen here, peaks at 80 ppm. 80 ppm are of solvent, and you have to ignore those peaks. You have to ignore, means you would be able to tell these are the peaks of the solvent, but these are of no use in your while predicting the compound. After that, let's move towards the next peaks. So students, the peak which is present at about 20 ppm, it is off. You have to remember the peak which is present at about 10 to 30 ppm will be of CH3, CH2, or of CH. So CH3, CH2, or of CH. Then in DEPT spectra, DEPT depth, so students, the depth spectra in carbon 13 shows us the peaks which will be headed downwards like this, these will be CH2s. Those which will be present above are CH3 or CH. So here, if it is the depth spectra, the peaks which are present below, these are the CH2. It is also present below the line, it means it is also CH2. The peak which is present above this line, it will be either CH3 or CH, and the line this is also present above, it means it is either CH3 or CH. So from 10 to 30, we basically CH3, CH2 or CH. And from 30 to 50 ppm, it represents us about CH2 or CH3 or CH with any electronegative atom. With electronegative atom, and the atom can be nitrogen, sulfur or bromine. From 30 to 50 ppm, it means either CH2 is with with nitrogen, sulfur or bromine. Like it is like CH2 bond NH, CH2 bond Br, CH2 bond S double bond O. It could be anything like this. Means from 30 to 50, if you are having a peak between 30 to 50, for example, if it is between 30 to 50, it means we are having anything like CH2 with anything with nitrogen, anything with sulfur or anything with bromine, or similarly CH3 with nitrogen, sulfur or bromine, or CH with nitrogen, sulfur or bromine. So hope this is clear here. After this, we are going to see the peak which is present at about 60 ppm, most probably which is above 50 ppm, and almost between 60, or if it is slightly above 60 ppm, it means it is any CH2, CH or CH3 with oxygen or chlorine, means with more electronegative atoms, oxygen or chlorine, other than the slightly less electronegative atoms which include nitrogen, sulfur or bromine. So this is the point which should be cleared here. The peak present at 10, 20 or 30 would be CH3, CH2 or any of the CH. Between 30 to 50, it would be any CH3, CH2 or CH with nitrogen, sulfur or bromine. And from 50 above and between 50 and 60 or anything slightly above 60, it means it is any CH3, CH2 or CH with oxygen or chlorine, means with more electronegative atom. Then the peak which is present between 100 to 120 shows us the peaks of carbon double bond carbon. The carbon double bond carbon in the aliphatic region, carbon double bond carbon in the aliphatic region, which means any of the carbon double bond carbon. It could be C, H, H, H or anything regarding this. So this will be the aliphatic region between 100 to 120 ppm. After 120 ppm, from 120 to 160, the carbon 120 to 160 ppm, the peaks show us from above 120 to 160. These peaks show us about benzene ring, aromatic region basically. Aromatic region, it's not necessary it is the benzene ring, because it could be any of the aromatic ring with the 5 carbon atoms, with 4 carbon atoms, or with even more carbon atoms. And the peak which is present above 180 or anything which is above the peaks of at the ppm value above the peaks of of aromatic region, it would be of carbonyl. It would be of carbonyl. So it will be present about 180 to about 220 ppm. It will show us the presence of carbonyl. So whenever you will see such kind of the spectra, those present from 1 to 60 will show us about CH3, CH2 or CH. Present from 1 to 30 show a simple CH3, solo CH3, solo CH2 or solo CH. Those present from 30 to 50 will show CH2, CH3 or CH with nitrogen, sulfur or bromine, which will be present above 50, between 50 and 60 or above, slightly above 60 will show us the CH3, CH2 or CH with oxygen or chlorine with more electronegative atoms. The peaks at present at 80 are of solvents, and we have to ignore these peaks as these are of no use. So the peaks which are present from 100 to 120 are the peaks of aliphatic carbon double bond carbon, which could be present in this form or any of the other forms. So 100 to 120 show us the peaks of C double bond C functional groups, and those present from above 120 to 160 are the peaks of aromatic rings. These could be 6-membered, 5-membered, or any of the rings of the aromatic region. So after these, we'll see the peaks which are present above 180 to 200. Those peaks which are present at the end are of the most electronegative functional group, and that's the carbonyl. So present which are present at the end, at the very end, are the peaks of from 180 to 220. These could be the peaks of carbonyl, and it's confirmed that it could be the peak of carbonyl. So you will have to predict whether this is the carboxylic acid carbonyl, carbonyl compound carbonyl, or which of the carbonyl is present here. So in the next videos, inshallah, we'll predict how to see which of the compound is the solution of the graph, and which will be the product or the compound of the following NMR graph. So this was all about today's video. So let us see what happens in the next videos and how we will be able to predict the compound using carbon 13 and hydrogen 1 NMR. So stay tuned, and if there will be any question, then do let us know in the comment section. So thank you so much for watching this video. So thanks.